Welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 4 from the October-November 2022 paper 4 variant 1, which is a mechanics 1 paper of Cambridge 9709. It's an A-level paper, and this question here is about inclined planes and dynamics and some friction in here as well. So we're told about a block of mass 8 kilograms, which is placed on a rough plane. We have a rough plane, which means we're going to be dealing with friction, which is inclined at an angle of 18 degrees to the horizontal. The block is pulled up the plane by a light string that makes an angle of 26 degrees above a line of greatest slope. A line of greatest slope. So I'm underlining some of the things which, either things that people don't understand what they mean or things which will be important in this question. The tension in the string is T newtons, and the coefficient of friction between the block and the plane is 0.65. Okay, so the coefficient of friction is 0.65. The acceleration of the block is 0.2 meters per second squared. Find T. All right, so here we have a situation where this block is being pulled up the plane. Okay, so the acceleration of the block is 0.2 meters per second squared, and it's being pulled up the plane by this force here. So what we're going to do first, in all these type of questions, what we should always do is we should draw the forces acting on the object. So we have here, of course, its weight going to act vertically downwards. So the weight's going to act vertically downwards. Okay, so that is, you can say 8g newtons, 8g newtons. And you also have, of course, this tension, which is already drawn there at an angle to the horizontal. And you also have the reaction force, which is acting perpendicular to the plane. Okay, that when you have an object in contact with a surface, then you have a normal reaction force acting always perpendicular to the plane. So we'll call this R, that's acting perpendicular plane. We are drawing here the forces acting on the block. There's also a reaction force acting on the floor, on the plane itself, which would act downwards, but we're considering the forces acting on the block here. And then we have also a frictional force, which is going to be acting down the plane. Okay. Of course, why is it acting down the plane? Because the object is moving up. So if the object is moving up, the frictional force will be in the direction opposing that motion. So that's called the friction. I'm going to call it F max. Why am I calling it F max? Because as the object is moving, the maximum value of friction that could occur has occurred. Okay, and what we should know is F max is equal to mu times R. And what mu is, this is the coefficient of friction. Okay, mu is the coefficient of friction, which is 0.65. Okay, so F max is mu R. So that's the force acting down the plane. Okay, so this is, we can say mu R. Mu times R. All right, so those are the forces acting on the object. Now, when we are considering the movement of the object and we're given the acceleration of the object in a particular direction, then we should always try to resolve the forces in the direction that the object is moving and also perpendicular to that direction. And the reason why we're concerned with the direction which is perpendicular is because of the fact that we have, especially with friction, because F equals mu R, R is perpendicular to the surface. So that's why we got to think also about the forces acting perpendicular to the motion as well. All right, so now, first of all, let's just consider what it means by line of greatest slope. So imagine you were looking at this from this angle over here. You're looking from this angle over here. All right, then what you would see in front of you, I'm just going to try and draw a 3D kind of diagram. You'd have a slope that's inclined at a certain angle to the horizontal. Okay, in this case, that would be 80 degrees. And this object will be pulled along this slope, pulled up the slope. So when it says a line of greatest slope, what it means is a line going straight up, you can say parallel to the sides of the slope. Yeah, it's not being pulled across this way or that way. It's like the shortest distance up the slope. That's what it basically means. Okay, so it's like along this line, which is the shortest distance up the slope. That's what that basically means here. So that's what they're referring to. It doesn't really affect the question in any way. But just for your information for those people who don't really understand what that means when they see it a lot in such questions. So hopefully that makes that clear. So what we're going to do is we're going to take these forces and we're going to resolve them in the directions which are perpendicular and parallel to the plane. So the reaction force and the frictional force are already perpendicular and parallel. We don't have to deal with those. But the tension in the string, I want to take this and I want to resolve it parallel to the plane. So that will be acting in the direction up the plane like this. So we have to find the component of the force which is parallel to the plane. It's like I have to go into the angle given. There's a tension here. I have to go into the angle given until it's gone through 26 degrees. And this is the force acting perpendicular or parallel to the plane. And we can think of this as, forming a triangle, which is a right angle triangle. Okay. And, we're considering perpendicular and parallel. So I'll draw a perpendicular line here. So if I want to consider the forces acting parallel to the plane, then I'm going to be looking at this, which is like the adjacent side. So I'm going to use cosine. Okay. Now, the easy way of thinking about this is that when you have to go into the angle given, you have to go through the angle given, then you use cosine always. So this is going to be t times cosine 26. T times the cosine of 26 degrees. And when you want to resolve the forces acting, parallel or perpendicular to the plane in this case, then we have to just change that, sorry. We want to resolve the force acting perpendicular to the plane. We have to go away from the angle given. So we can use sine. You can also think of this as we're trying to find this component, which is opposite the angle given. So we use sine. So this will be t times sine of 26. Okay, so I've resolved the tension parallel and perpendicular to the plane. I'm going to do the same for the weights now. So I'm going to resolve the weight in this direction here, which is going into the angle given. Okay, it's going. All right, so first of all, before I talk about the angle given, let's just work out what the angle is, or explain what the angle is. So I'm going to draw a little line here to make that clear, because that's another thing that a lot of students don't understand. So I'm going to explain what the angle here is and why it's the angle that it is. So here we have a line which is kind of like in the same, which is like the extension of the reaction force. Okay, so the angle between the weight and this line, which is perpendicular to the plane, this angle over here, okay, this angle is always going to be the same as the angle to the plane is inclined to the horizontal. And the reason it is so, I will explain. Okay, just imagine I consider this big triangle. Okay, I'm considering this big triangle and I'm comparing it with this small triangle over here. Now, this big triangle has a right angle in this corner here, and it also has an angle in this corner. And this small triangle has a right angle over here, and it has the same angle in this corner, this small triangle. So this big triangle and this small triangle are similar triangles because they both have the same two angles which are the same, right angle and this angle. So this has a right angle here and this angle, and the small triangle has a right angle over here and this angle. So they are similar triangles by angle. So if two of the angles are the same, the third must be the same as well. So if this is 18, then this must also be 18 degrees. So this angle here is 18 degrees. 18 degrees. Okay, so that's why the angle is 18 degrees, right? So that's a little explanation there for you to maybe help you understand. So I'll just get rid of this. Okay, so if you didn't understand that, I'm going to have a link at the end of the video where I will show you basically, it'll link you to a video where you can see the explanation of that in a bit more visual way. Anyway, so now we want to resolve these forces now in the directions which are parallel and perpendicular to the plane. So if I consider this force, this is the weight, and I want to resolve it in a direction which is parallel to the plane, then I've got to go in this direction over here. which is going away from the angle given. Going away from the angle given. The angle given is 18. It's the angle. So I'm resolving away from the angle. So this is going to be using sine. Okay, you can think of it as I mentioned up there. If you're not comfortable with that, you can think of it as we're considering this triangle over here, and this side is the opposite side, which is parallel to the plane. So we're going to use here a sine. So we'll say this is 8g, which is the force, times the sine of this angle 18. And if we're resolving the force, which is, a second, let me just get that back. If I'm taking this weight and I'm resolving it in the direction which is perpendicular to the plane, I have to go into the angle given. So when I'm going into the angle given, I have to use cosine. So this is going to be 8g times cosine of 18 degrees. 8g times the cosine of 18 degrees. So now I have all the forces resolved in their various directions, or in the directions which are parallel and perpendicular to the plane. And that's a very important step here and worth a lot of marks when we set up the equation. So now I'm going to do is I'm going to set up the equations that we need to now solve the problem. Okay, so we've done all the groundwork. So I'm going to take a copy of this diagram and move it down so that we don't have to keep scrolling up. Okay, so now we want to find what t is. So what we're going to do now is we're going to set up some equations to help us. Okay, so what I'm going to do first is I'm going to resolve the forces perpendicular to the plane, which are basically the forces acting in this direction. So we have R acting up. Now the common mistake people make is they say R is equal to 8g cosine 18. And they forget about this force here. This is also has a component perpendicular to the plane. So if the force acting parallel to the plane here, if it was acting only parallel to the plane, it wouldn't have a component perpendicular to it. But because it's acting at an angle to the direction of motion, therefore they will have a component also acting up here. So be very careful not to forget that. So it's R plus T times sine of 26. Those are the forces acting in the upwards direction, and downwards is a component of the weight, which is, so that's going to be equal to 8g times cosine 18. Now, why are they equal to each other? Because, in this case, the acceleration in this direction is 0. In this direction, the acceleration is equal to 0 because it's going in a direction parallel to that or perpendicular to that. Okay, so that direction here, the forces up and down, or forces perpendicular upwards and downwards, will be equal to each other. Okay, so that's an equation we've formed from the forces perpendicular to the plane. If we look at the forces parallel to the plane, then in this case, we know that F equals, the resultant force is equal to the mass times acceleration. The resultant force is equal to the mass times acceleration. In this case, the resultant force was equal to 0. In this case, it's equal to the mass times acceleration is accelerating. So in this case, I've got to find the resultant of the forces parallel to the plane. They're not equal to each other now. Okay, they're not equal to each other because it's accelerating in that plane. Right, so I'm going to look at the forces acting upwards, which is just t cosine 26. So t times cosine 26. And then I've got to take away the forces acting downwards. So I have the component of the weight, which is 8g times the sine of 18 degrees. Okay, and I've got minus F max, which is mu r. I'll call it mu r. Okay, and I know that the resultant force is equal to the mass times acceleration. Now the mass of the object, the mass is 8g, is 8 kilograms, and we know that g is equal to 10. Okay, so it's going to be basically the acceleration, as I said, is 0.2. Acceleration is 0.2. So it's ma, it's F max, the resultant force, is equal to mass times acceleration. So it's 8 times 0.2. Okay, so now I have these two equations which I can now try to solve for t. Now we have two unknowns, r and t. We want to find what t is. So we're going to try to eliminate r from our equation. So what I'll do is I'll take this first equation, I'll make r the subject. So I have r equals 8g cosine 18, 8g cosine 18, okay, minus t times the sine of 26. Okay, and what I can do is I can replace this r with this, and we know that mu is equal to 0.65, as they told us in the question. The coefficient of friction is 0.65. So I can now replace those values in this equation and hopefully find what t is. So I have t times, I'll leave this as cosine 26. I'll leave that until the end. I don't have to write all these decimals down. Minus 8g. Now 8g is 10, remember? So you have 80 times sine 18 minus 0.65 times r. Now r is equal to all of this. So you have 8 times g, which is 80, cosine 18 minus t times the sine of 26, and that's equal to 8 times 0.2, which is 1.6. So now we see there's only one unknown. So I'm going to now expand this bracket and simplify. So I'll leave this as it is, as I said, t times cosine of 26 minus 80 times the sine of 18 minus, now I have 0.65 times 80. So 0.65 times 80, which gives you 52. So that's 52 times cosine of 18. And be very careful here. These questions are very easy for you to lose marks. And you have minus times minus, which is plus. Be careful there. And you have, I'll just leave it like this, 0.65 times t times the sine of 26. And that's equal to 1.6. So now what I'm going to do is I'm going to gather the t terms on one side and all the other terms on the other side. So here I have t times, and then what I'm going to do is I'll take these together and kind of factorize the t out. So I have t times cosine of 26, and I have plus 0.65 times the sine of 26. Okay, so these two terms I've combined, taking out the t as common, and the rest of them I'm going to add them to both sides to get rid of them. So I have 1.6, I'll have plus 80 times the sine of 18, and also plus, this is 52 times the cosine of 18. So now what's left for us to do is find t. So we can divide both sides with what's multiplying the t here. So we end up with 1.6 plus 80 times sine of 18 plus 52 times the cosine of 18 all over all of this, which is the cosine of 26 plus 0.65 times the sine of 26. And that should give us the correct value of t. And now, as I said, this is one of those type of questions where it's very, very easy to make a wrong, kind of like make a silly mistake, like write down sine instead of cosine, or mix up the angles, or, you know, mess up with minus signs when you're multiplying and so on. So be very careful about this. So 1.6 plus 80 times the sine of 18, and you got plus 52 times the cosine of 18, divided by, you've got cosine of 26 plus 0.65 times the sine of 26. And that should give us the correct answer, which is 64.014. 64.014, it goes on and on. So we want to give our answers always to 3SF, so 64.0 newtons, and that is the value of the tension. That's quite a long question, right? Quite involved, 7 marks, but you have to just be very careful when you're doing it. So this resolving the forces is like very important. So sometimes when you do a question like this, you're not sure how you're going to get the answer at the end, right? So always, these type of questions, resolve the forces parallel and perpendicular to the plane. And then when you've got your 2 equations, you can then see how to manipulate them to find what you're looking for. So here we're looking for t, so we have to eliminate r. So we can do it by making r the subject of one of the equations and substituting it into the other. So that's what we did here. We took this equation, let's call this part of 1, and this is equation 2, and we took equation 1 and we put it into equation 2. Over here we took 1 we substituted equation 1 into equation 2. This is equation 1, replacing the r in equation 2, and then we were able to make t the subject and get the correct answer. And notice also that I kept, that in the whole of this question, I kept all the terms, instead of writing them as decimals and rounding them in the beginning, I kept them in terms of cosine and sine until the end. Then round your final answer. That always helps you to keep accuracy in the answer. That's something that they're looking for when they give you such questions. Okay, so there's the answer to this question, part A. Now we're going to go on to part B. Now part B says the block is initially at rest. Find the distance traveled by the block during the 4th second of the motion. So this block is, again, it's going up the plane. Okay, and I'll just make a little diagram of it myself here. Good copy, I guess. But it's going up the plane. All right, and it's going up. We know the acceleration of the block. I don't think we need to work out anything like that. We know the acceleration of the block is 0.2 meters per second squared. So initially it's at rest. That means at the beginning, find the distance traveled during the 4th second of the motion. Okay, so now I think we have to use a suvat equation. It has a constant acceleration. So we know that acceleration, we don't have to really calculate anything. So I don't really need this, to be honest. Just get rid of this. So we know that the acceleration is 0.2. So what I'm going to do is I'll write down suvat. Okay, so we want to find the distance traveled during the 4th second. Now this is very important. A lot of students mess up with this question here. During the 4th second of the motion. What does that mean? It doesn't mean for the first 4 seconds. It means during the 4th second. Now, if you think about it, the first second, okay, of the motion would be between 0 and 1 second. The second, you could say the second of the motion would be between 1 and 2 seconds. That's the second. And the third second would be between 2 and 3 seconds. And the 4th second would be between the 3rd and 4th second. So what we got to do is we got to find the distance traveled over the first 4 seconds minus the distance traveled over the first 3 seconds. And that's going to be distance traveled in the first, or during the 4th second. During the 4th second. That's what we're looking for, right? So we need to find the distance traveled over 4 seconds. So like, for example, it's traveled this distance over 4 seconds, say. Okay, so that's the distance traveled over 4 seconds. And here's the distance traveled after 3 seconds. Okay, so this distance will be the distance traveled between the 4th and the 3rd second, which is, that means that's during the 4th second of the motion. Okay, because the first second is like between 0 and 1, second between 1 and 2, third is between 2 and 3. So the 4th second would be between 3 and 4 seconds. So that's what we're looking for here. Okay, so we need to find S4 and S3. So we know we want to find S4. We know the initial speed is 0. The final speed we don't know. The acceleration we know is 0.2. And the time we know is for the first 4 seconds. Okay, so if you look at these, which of the formula that we're going to use? Well, we have the formula sheet. If you look at it, you'll see very clearly that it's the formula that has S, U, A, and T, which is S equals UT plus a half AT squared. Okay, so for the 4th second, it's going to be 0 times T, 0 times 4, plus a half times 0.2 times the time, which is 4 squared. So for the first 4 seconds, it's going to travel at 1.6 meters. 1.6 meters. Why? Because that's 0.1 times 16. Okay. All right. And if you want to find S3, well, S3 is going to be 0 times the time, which is 3, plus a half times acceleration, which is 0.2 times 3 squared. Okay, so that's going to give us 0.9 times 0.1 times 9, which is 0.9. It's going to be 0 plus 0.1 times 9, 0.9. So therefore, you can say that the distance in the 4th second is going to be 1.6 minus 0.9. 1.6 minus 0.9, which is going to be, I think, 0.7. So you have 1.6 minus 0.9 gives you 0.7. So 0.7 meters. So there's the answer to this question, part B. So we don't really need the force diagrams or anything. We already know the acceleration. So even if you couldn't work out part A, you could answer part B, get at least salvage, 2 marks, okay, from the part B of the question, because it doesn't really require any understanding of part A, except knowing the acceleration, which we already know, and that's what they told us in the question. Okay, so there's the answer to part B, and that completes this question from the M1 paper of October-November 2022 of Cambridge. This is paper 4 variant 1. So other questions from this particular paper will be found in the playlist that will appear in this top right corner of the page at the end of the video. Other questions from the topic of dynamics you'll find in the playlist over here. Questions involving friction, forces and friction are put in this playlist over here. And also for questions involving constant acceleration, I'll put in this playlist over here. So it involves all those different topics. Thank you for watching and see you soon.